A club is arranging a charter flight to Hawaii. The cost of the trip is $575 each for 83 passengers, but they get a refund of $5 per passenger if they can get more than that. So any passenger in excess of the 83 knocks $5 off of the cost for each person. And they're going to ask us to find the number of passengers that maximize revenue, and then later on to find the maximum revenue. Now, I think the hardest part of this problem is the setup, so I want to spend maybe more time on that part. We have a price for 83 passengers, but this discount occurs for getting more than 83. So ultimately, we want to find the number of passengers, so let's just go ahead and call that X. So if X is the number of passengers that end up going on the trip, that'll work out nicely because they're asking about that. Now, the discount doesn't apply unless they get more than 83, and it's $5 for each person over 83. So you might think of it this way: the discount per person is $5 times the number of people over the 83 mark. So if X is the number of people, you subtract off 83 to get the excess. So if 84 people went, there would just be one $5. If 85 people went, there'd be $10 off per person, and so on. So this X minus 83 represents the excess of 83, the number of people over 83, and each of those people generate a $5 discount per person. So think about that. You've got X passengers, but the discount per person is based on the people over 83. Okay? So if we let little p be the price per person, then it's going to be the base price of $575, that's the quoted price, minus the discount per person, which we've already calculated to be this 5 times the quantity X minus 83. So this is the base price minus the discount. So the price per person goes down from the $575 based on the amount of discount per person. Now if we multiply through by minus 5 and simplify this, you get $575, and then you get a minus is plus 83, and that turns out, plus 83 times 5, and I'll let you do the arithmetic. Minus 5 times minus 83, and if you add 575 to that, you'll get 990, and then you got minus 5x. So that turns out to be the little p, that price per person. But we're trying to maximize the revenue. Now the revenue is the price per person times the number of people, or the price per passenger times the number of people. We typically use capital R of X for revenue. The revenue is the price per person times the number of people that go. Well, we just calculated this little p just above, so the revenue function would be 990 minus 5x multiplied by x, which if you simplify it becomes 990x minus 5x squared. By now you know the routine. You take the derivative and set it equal to 0. The derivative is 990 minus 10x. So you want to set that equal to 0. So if you take 990 minus 10x, set it equal to 0, add a 10x to both sides. That's 990. And then divide both sides by 10, you get x is equal to 99. So 99 passengers should provide the maximum revenue. Now if you want to be absolutely certain that that's a maximum, all you have to do is take a number on each side of 99 and do the first derivative test. So if you take a number smaller than 99 and put it into the derivative, say for instance 0, you get 990 minus 0. That's definitely positive. If you take a number bigger than 99, say 100, 10 times 100 is 1,000. 990 minus 1,000 is negative 10. It's definitely decreasing. That is a maximum. So find the number of passengers to maximize revenue, 99. Okay. The B part says find the maximum revenue. So all you have to do is find the revenue function, which is here, and put 99 in. So you get R of 99 is 990 times 99 minus 5 times 99 squared. I'm not going to belabor the arithmetic there, but if you carry it out, you'll end up with $49,005, and that would be the maximum revenue. Look over that very carefully and make sure you understand every part of it.